Alright class, so today we're going to be solving two-step equations. I want you all to understand the difference between a one-step and a two-step equation. So earlier on we've gone over one-step equations where you use inverse operations to be able to solve problems. So first of all, let's go over stuff real quick. So what is a variable? Real quick, Catherine.
A number you don't know.
A number you don't know, right? Let's call it x, right? So Danielle, what is an expression?
An expression is it has like a variable and numbers, but there's no equal sign.
No equal sign, great. So if I tell you x plus 5 is an expression, is that correct?
Yeah.
Yes. So you said that an equation has an equal sign, correct? Okay, good. If I write x plus 5 equals 2, that is an equation, right? So in this case, would you say that 2 and x plus 5 separately are expressions?
Yeah.
Yes, right? So in this case, an equation is two expressions that are equal to each other, right? So let's go over one-step equations again. This is a one-step equation. So what I said before was you solve a one-step equation by using inverse operations. Catherine, what is an inverse operation?
When you do the opposite.
You do the opposite, right? Great. So we're talking about the function though, right? So when you're adding, what would be the opposite of adding, Danielle?
Subtracting.
Subtracting, correct? So in this case, what would you do to solve this one-step equation? Brittany?
Subtract by 5 on both sides.
Subtract by 5 on both sides. Why would you do it on both sides? Because you want to be able to isolate the x and be able to get the number on the other side, right? So in this case, you subtract by 5 and you get x equals -3, right? Good. Okay, so real quick, we're going to be going over the steps to solving a one-step equation, and then we'll go over the steps to solve a two-step equation. So for step 1, you need to identify whether or not the problem is an equation. So Danielle, you said before that an equation has an equal sign, right? So if I write is this an equation? Don't worry about what's actually on there yet. So if I write 2x plus 6 equals 2, is this an equation? Yes, right? Because it has an equal sign. So in this case, what would be step 2? You identify the side with a variable. So Brittany, where's the variable in this equation?
On the left side.
Right? Because the variable is a number you don't know. The variable x is on the left side. So now step 3. What we did before with the one-step equation was we used inverse operations to solve it. So in this case, Danielle, what is the inverse operation needed to do the first part of this problem?
First you need to subtract 6 from both sides.
Subtract 6 on both sides. Why? Because in an equation, both sides, both expressions are equal to each other. So if you subtract 6 on both sides, you're making sure that the problem stays balanced, correct? So you subtract 6 and you get 2x is equal to -4. So now that you have balanced your equation, you have your x on one side and your number on the other side. Catherine, what is the next step?
Divide by 2.
Divide by 2. So in this case, all you did was a one-step equation, but you took it one step further and just did inverse operations again. And that is your step 4. So step 1 is you identify whether the problem is an equation or not. Step 2 is you identify the side with the variable. Step 3, you isolate the variable by using inverse operations. And step 4, you solve by using inverse operations again. It's that simple. 4 steps. So let's go over another example. We have 7m minus 17 equals 260. Right? So in this case, Danielle, step 1, is this an equation?
Yeah.
Yes, good. So step 2, Catherine, where's the variable?
Left.
On the left side, right? Your variable is m. Variable can be any number that you don't know. So step 3, you isolate the variable by using inverse operations. So Brittany, in this case, how would you isolate the variable?
Add 17 to each side.
You add 17 to each side. Great. You get 7m equals
77.
77. Great. Okay. So Danielle, what is your next step here?
You divide both sides by 7.
You divide both sides by 7, right? Because you're using inverse operations one more time to get your answer, which is m equals 11, right? Great. So now what we're going to do is you'll have figures on your desk, and real quick what I want you to do is take them out, and I want you, by using all of your figures, to recreate this shape. You have 4 vertical bars, and you have 2 small squares. So recreating this shape should be pretty easy. So how do you do that, Catherine? How did you create this shape?
I put 4 bars next to each other, and then the 2 little ones at the end.
4 bars next to each other, 2 little ones at the end, right? So what if I tell you that each long bar equals to x, and that each little square equals to 1? And what if I also tell you that this figure equals to 26, right? So you have 4x, right? So then how many little squares do you have in the figure? 2, right? Great. So 2. And then I'll tell you that the entire figure is equal to 26. So all of those together in that shape equals 26, right? So then to get your answer, what x is equal, you want to know what one of these bars is equal to right here, correct? You want to subtract 2, so you just take away 2 small squares. You took out 2, right? And then you divide by 4, and you find that x equals 6, meaning that for each vertical bar, you have 6 small squares within them, right? So now we understand how to solve two-step equations. You just watched my breakthrough lesson on solving two-step equations, and this is my reflection. So first of all, I want to go over what did not go well. So the first and most important thing, honestly, was time. I realized that as a teacher, it is very difficult to sequence the material in a manner that will be both time effective and not detrimental to the content of the lecture, or the lesson, sorry. It is hard to use the basic concept of the material without wanting to go further and apply it to a word problem or something that they could understand more easily, like I tried to do with the manipulatives. You could tell that I had to make significant cuts on the video in order to preserve time and to get the basic gist across of the lesson, although I only cut one extra example out of my original lesson plan. So I may have also spent too much time on one-step equations and things that the students were already familiar with. However, this may make it a smoother transition because it allows the students to see what everything they are learning is a continuation of things that they're already familiar with. I should have debriefed what they had just learned a little better before moving on to the next activity or part of the lecture. This way I could reinforce the steps to learn the material. At the end, I did not debrief as much. Things that went well. I got the students to answer questions about what they were already familiar with. I involved them. I asked them to tell me what they already knew. I got them involved with the build-up of what we were talking about, and I used their prior knowledge to introduce the topic. And I used the manipulatives, which in my opinion is very important because it allows the students to work with their hands. Someone once told me that people tend to remember more what they get to do, not what people say, at least when it comes to lectures or places where you get information. So giving the students a hands-on experience is extremely important because it allows them to have a visual right there in front of their hands, in front of them, that they can get to work with and just play around with for a little bit. And it also allows me to use the manipulatives for later, more difficult problems in order to break them down more effectively. So I'd like to thank you for your time and considering me as an applicant, and thank you very much.